We should be on this page, right, where we left off yesterday. Yesterday we talked about Cramer's rule, but only how to solve a system with two variables. And then we went into finding the determinant of a 3 by 3 matrix. So now to finish this off, there's a way to use that Cramer's rule with a 3 system, or a variable with 3, I'm saying that wrong, a system with 3 variables. So if we have like an x, a y, and a z, we could obviously use a lot of different ways. We've talked about using substitution, elimination. We could graph it. We could do the Gauss-Jordan elimination substitution process, or we can now use Cramer's rule. And that's what we're going to do today. Now, to do this, it involves a lot of determinants. Finding a lot of determinants using either the diagonal or the expansion by minors method that we talked about yesterday. So again, this is kind of a general form of what Cramer's looks like for a system in 3 variables. If I have an x, a y, and a z, I'm going to need to solve for all 3 of those letters. And so that involves finding different types of determinants. Now, if you notice on my setup here, all the bottom determinants say d. Like in the fractions, they all have a determinant d at the bottom. D's determinant looks like this. You just grab all the coefficients from in front of the x, y's, and z's. You do your diagonals method or your minors method, and you find that determinant. So that's going to be the first one that we maybe want to start with. We only have to solve for it one time, and then we just use it for every single letter. Then the other ones that are on top, they change a little bit. We have a determinant in respect to the x, we have a determinant in respect to the y, and we have a determinant in respect to the z. And if you remember when we did Cramer's rule yesterday with the 2 system, the only thing that changes in your determinant is depending on what letter you're solving for, you don't use those coefficients. So when you're solving for x, you don't use x's coefficients when you're setting up your determinant. So notice on this dx here, we're replacing all of the would be like a, b, c, like from my x's, with those numbers that are outside of the equal sign. And when we look at the y, same thing happens here. You're replacing the y's with all of those numbers from the end. And then with your z, you do the same thing. That's really the difference, again, in setting it up. We just have larger matrices that we're working with here. But Cramer's rule did the same thing when we did a 2 system yesterday. Instead of putting in our x's, we would put in those numbers after the equal sign. And same with the y. Again, once you find the determinants of each of these things, then you just plug it into these fractions. So you take each individual determinant for x, y, and z, and you divide by that determinant that we solved for at the beginning. So it looks kind of like I know it looks like a lot right now, and there are quite a few determinants. So it'll take us a little bit of time to get them all done. But again, you can choose like what method you want to use. Remember I said yesterday, I prefer the diagonal method. So that's probably the one that I'm going to use like we did on your bell ringer today. So let's do an example. And we've got some of it kind of worked out for us, and then we'll eventually do some of the work on our own as well. So we're starting out with this system up here. So this is where we're beginning all of this information. And I'm going to start by just finding my regular determinant because I'm going to need to use that for all of them. And so I'm just grabbing all the coefficients in front of my x, my y, and my z. So that's where all these numbers come from. 3, 2, 1, negative 2, 3, 4, 1, negative 1, 3. All of those come from the numbers in front of your x's, y's, and z's. They're showing you using the diagonal method. So again, I'm just going to keep doing what we did yesterday. Oops, see if I can, I don't know if it'll let me highlight. There we go. So this is my first set of diagonals. So this would be 27. This one would be 2. And this one would be 8. And so when they add 27, 2, and 8, that's where they got this 37 from. Okay, so these added together is where we're getting 37 from. Then we switch to our next set of diagonals. So going this way. I'm not going to do this for all of them. I'm just showing where they're getting these numbers from. Okay, so then this one would be 3, negative 12, and then another negative 12. And so if you add those together, That's where they're getting that negative 21 from. And then the rule for determinants is always subtracting. So you add those numbers together, then you subtract. So the regular determinant is 58. So this is like the first one that we needed to find. And when we go down, I'm just going to scroll down for a second. When we go down here, you're going to use 58 on all the bottoms of the determinant. So even on this last one that they didn't set it up for us at all, when we're doing dz over d, it's going to start out over that 58 that we just found. So we could go ahead and set that one up too. So you want to start there. Now, if you look underneath this, we've got the separate ones, one for x, one for y, one for z. Now, again, they're kind of doing x for us. So I'm just going to highlight those diagonals that they used. Okay. And then you get your numbers when you multiply. You add them up, they get these numbers over here. So we got 116. So again, this number is what I really needed at the very end. Now that's my dx. So down below again, the 116 got put here because I'm talking about finding x. So then when they took 116 divided by 58, they got 2. So x was a 2 down here. Now, they're telling me down below what the d of y comes out to be. It says that it comes out to be a negative 174, but they don't show any of the work up there for it. So let's go ahead and do that one. This will give us some more practice with what we did yesterday. So I'm going to start first by, they wrote out my matrix over there. And again, the only thing that's changing is, on the x, they put those numbers after the equal sign first. They're putting them in the middle for the dy. And they're putting them last for the dz. So those numbers that came after the equal sign, that's where they're being placed at in these individual determinants. So now let's set this up and see what we can do with it. Again, I like the diagonal method, so I'm just going to do that. I'm going to rewrite those first two columns. This is what we did yesterday. And now we're going to start doing our diagonals. So let's start doing these. Let's go ahead and do the math here. What would be 3 times negative 9 times 3? Or you can rearrange that if it's easier. Negative 81. Plus 16 times negative 1 times 1? Negative 16. And then the last one would be 4. So if we add those together, what do we get? Negative 93. Okay, so I'm just going to write that here. Negative 93. Okay, let's switch to our next set of diagonals. Going this way. What would these products be when you start multiplying along the diagonal? Okay, so again, we're adding those together. What does that come out to be? Positive 81? Yeah. Okay, so then to finish it off, we take negative 93 minus 81. What is that? Good, negative 174. And that's that number that they had down here. So it matches what they already had on my page for me. And then again, I'm still using the 58 from the very first determinant that we did. And we got negative 3 for my y. So we've got one last one to do, and that's z. And again, they've got it set up for me. They put my x coefficients, my y coefficients. They replaced the z coefficients with those numbers that followed the equal sign. That's why I circled it, just so you kind of know it's different than what you did on your very first determinant. We're going to do this the same way. I'm going to set up my matrix. Okay. Let's take care of these first. What would these products be if you start multiplying along the diagonals? 3 times 3 times 2? 18 plus, I think it's positive, right? Because it's a negative times a negative. Plus, okay, so if we add those all together, should be 164, I believe. Okay, and then the other set of diagonals. 48. Okay, and then, so I know I squeezed that in there. I'm running out of room here. So what does that come out to be? Okay, again, then we finish it with 164. You always take the product, like the sum of those products from the bottom, like your first set of diagonals, minus the other set. So what's that? 232. So down below, that's what's going to go on the top of the z, 232. What is 232 divided by 58? 4. And that's what they have written down below as well, because they wrote it then as an ordered triple, your x, your y, and your z. Questions on how we use Cramer's rule for the system with 3 variables?